So good morning, friends. Uh, Today we are going to start the syllabus of engineering mathematics for SPPU University, Savitribai Phule Pune University. The first chapter of that engineering mathematics we are going to start. The first unit has four parts in it. We have a mean value theorem, then we have a expansion series, and then we have indeterminate forms, and then we have Fourier series. So out of that, the first part, that is the mean value theorem, we are going to start today. The mean value theorem has three theorems mainly, which are Rolle's theorem, then Lagrange's mean value theorem, and Cauchy's mean value theorem. Out of that, mostly you will get the question in the exam based on the Lagrange's mean value theorem, but still we are going to start with Rolle's mean value theorem. So let us see what is the Rolle's mean value theorem. So as per this Rolle's mean value theorem, if there is a function, if there is a function f of x defined within an interval a comma b, if it is the case, and along with this few more conditions are there, and if it satisfies these three conditions, like first condition is if f of x is a continuous function, then secondly, if the same f of x is a differentiable function, and also there is a third condition in the Rolle's theorem, that if f of a is equal to f of b. If these conditions are satisfied, then as per this Rolle's theorem, there exists a C point, a point C which belongs to a comma b, such that f dash of C is equal to 0. So this is the Rolle's theorem. Now let us see a small example of this Rolle's mean value theorem. Now let us consider an example of this Rolle's mean value. So let us see the example. The example in the exam will be like this. Verify Rolle's theorem for f of x is equal to, let us say, sine of x, and within we can say 0 to pi. Okay, so this kind of question you will get in the exam. So let us see how to solve this kind of question here. Now to solve this, to verify this Rolle's mean value theorem, first thing we need is to check whether the given conditions satisfy the given function satisfies the Rolle's conditions. So here f of x is equal to sine x is given, and the very first condition, first condition is what? To check whether the given function is continuous. So the continuity is the first condition. So as we can see, the function sine of x is continuous everywhere. That means it doesn't break anywhere. We can put any value from minus infinity to plus infinity, and for any value of x we will certainly get an answer for this sine of x. So remember all the sine cos terms, all the polynomials are continuous. So likewise here the f of x is equal to sine x function is also continuous. Reason we can write sine x is continuous everywhere. Therefore uh, therefore sin x, or what we can say f of x, is what is continuous, is a continuous function within 0 comma pi. That way we can write the first condition. Then the second condition is to check the differentiability, whether the differentiation is possible and uh, the differentiation has a valid answer, that we can check here. So you can see that f dash of x, if I want to find out this f dash of x, the derivative of this sin x is, you know that it is cos x. Again this cos x is uh, also continuous everywhere for all the values of x. You can check anything like cos of 100, cos of 200, whatever you want. You can check the value of cos. It is continuous everywhere. That's why we can say which exists. This f dash of x exists within 0 to pi. That's why we can say that this is what differentiable as well. And the third condition is what? The third condition is to check whether f of a is equal to f of b or not. So for that, f of a, here you can check that this is what a is equal to 0, and then b you can say it is equal to pi. And if I put f of a, if I want to find out f of a, that means we have to put 0 instead of x in this equation. So we can see that it is sine of 0, x replaced by the 0, and sine 0 is nothing but 0. Likewise, if I try to find out f of b, it is equal to f of pi. That means it is sine of pi, and the answer for this sine pi is also equal to 0. Then if this all the three conditions are satisfied, then here comes the actual, what we can say, the twist of this problem. So if these three conditions are satisfied, then we can say therefore as you can see that these two are equal, so all the three conditions are satisfied. Then as per Rolle's theorem, we can say that as per this Rolle's theorem, there must be some c which belongs to which belongs between a and b, such that f dash of c is equal to 0. F dash of c equal to 0. That means there, as per Rolle's theorem, there exists c which exists between a and b. Okay, there must be at least one point c which lies between a and b, such that f dash of c equal to 0. And to check whether it is true or not, what we can do, we can put the value. We can directly take this equation, and instead of this x, we can put c here. So f dash of c can be written as what? Cos of c. And this is we are going to equate this to the 0. And then if I solve this, I will get c is equal to cos inverse of 0. And do you know what is cos inverse of 0? Cos inverse of 0 is nothing but what? Pi by 2. So c equal to pi by 2 is such a value for which f dash of c we are getting at 0, and definitely this c equal to pi by 2, it belongs to 0 comma pi, which is a given interval, the given interval 0 to pi. So from this we can definitely say that the Rolle's theorem is verified here. Hence the Rolle's theorem is verified. Okay, so what we have to do, first of all, we have to check whether the given function is continuous, then we have to check whether it is differentiable, and then we have to check whether f of a is equal to f of b or not. If these three conditions are satisfied, then we directly equate f dash of c equal to 0. and by solving this, whatever the value of c we are getting here, that we have to see that this value must and should be within 0 to pi, and that is proved. So this Rolle's theorem is verified. A little consideration can show here that the illustration of this problem I have given here in this curve. So this function f of x, you know, it is a sine wave. It can be represented like this. Part of that sine wave only is considered for this problem, which is between 0 and pi. So this is a sine wave between 0 to pi. So as per the Rolle's theorem, what they are saying that if any curve is continuous and differentiable, and if f of a, you can see here f of x, that is sine value is 0 and 0 here. So if these two conditions are satisfied, then they are saying that there must be at least one point between 0 and pi such that the derivative, or what we can say the tangent to this curve at that particular point uh, is having slope equal to 0. That means it must be parallel to the x-axis. So here you can definitely see that at pi by 2, if I draw a tangent to this curve, so it will be perfectly horizontal curve. So this is a horizontal curve, horizontal tangent, and this has the 0 slope. So f dash of c, that means f dash at this pi by 2 is equal to 0. So this is the illustration of this problem. So thank you. We'll see more problems of this series in the next video. Thank you.